যেটা হচ্ছে নাম্বার 1 রিভিউ আচ্ছা লাস্ট ক্লাস লেকচারটা রিভিউ আপলোড
Yes, sir. I upload.
very good and number 2 is processing expression processing and evaluation using a stack. So we want to see how we process and evaluate using stack. So the first part is a review because if you have any questions, let's look at first review. In the review, so I will ask you maybe one question is that infix, and then we have prefix, and then we have postfix, right? So my question actually is that why do you need expression processing? That's a basic question. How do you answer this question? Why do you need expression processing at all? What is the reason? Why do you need expression processing?
It's calculated easy. It's calculated.
An example, for example, let's consider this. Let's say 3 multiplied by 2 plus 6 division 3. For example, this is an expression. My question is that why do you need infix, prefix, postfix at all for this expression? Why expression processing? Any answer? Why do you need expression processing? To calculate the output of this, right? That means there is a final output, right? But how can I use my computer to directly take this as an input and generate output from this? Suppose this is your input to the computer and your output will be, what will be the output? 8. So in order to generate this final output, you need to process this expression. You take an input is an expression. That expression consists of operands and operators. We don't have any teacher. The computer. We actually give all operators and operators. And computer must be able to generate a correct output. The reason why we need to do expression processing. Now, when we see that this expression, what you name it, how do you call this expression? Which one? In this three.
Infix.
Infix expression. Now, we need to convert this expression into prefix or postfix. Depends how we are applying. For example, imagine when you write a C program. You're writing a C program and you need to compile it. So you are giving a piece of expressions, consist of variable declaration, logic, and so on, to a compiler. Compiler is a machine. Compiler takes that as an input. And compiler actually is parsing your program before compiling to understand this program is ready to run. So how actually it does this? It does this through expression processing. So there is a infix or there is a postfix or prefix operation which is inside the compiler to generate a right expression or a wrong expression. So before compilation of any program, stack is used inside the compiler. Every compiler has a stack inside because they want to generate from infix to either prefix or postfix before actually evaluating. Okay? So is it clear? And any other questions you may have? Any other questions?
স্যার তাহলে কি কম্পাইলার আসলে প্রথমে একবার প্রিফিক্স করে অ্যান্সার বের করে দেখে আর একবার পোস্ট ফিক্স করে অ্যান্সার বের করে দেখে যদি সঠিক থাকে তখন সেটা রিপ্লে দেয়
Take it as a correct answer. So that's very, very important that you understand this. Because see, whatever topic we discuss in our entire course of computer science engineering, our target is to understand that where it is being applied. Whatever topics you come across. It may be database, it may be C programming, it may be operating system, it may be compiler design, it may be AI. Every topic has an application. But if you do not have understanding of the application, then you don't feel about this topic. Yeah, that's very important. Alright, so any other questions you may have, then I will take you into very quickly into a discussion of the second half, that how we use stack to process and to implement. Okay? So let's proceed now then. You remember how we convert an infix to prefix and postfix?
Yes, sir.
We just move the operator to left or right, right? So let us begin our discussion on using stack, and this is very interesting and fun also at the same time. So let's look at an example. We take up an example. The example is you remember the first example we started with. Can you tell me the expression? What expression? Plus 4 into 2 plus 6 by 3 minus 8. Okay. So let's consider this is an infix. Yeah, infix expression. And then we do parentheses. So parentheses means what we do, we put actually parentheses, right? Based on the precedence of the operation, minus 8, and then put both parentheses. Now imagine that's actually your input to computer. You are actually giving this expression as the input to the machine. That is, when you input also this bracket. So I'm going to show you that what happens if I give this expression and then how do I use a stack to process it. So there are certain rules. We have to write down those rules. First rule is that if this bracket comes open and this is a closing bracket, all the opening bracket will actually go inside stack. So if I'm writing, if this, then push. That means if this, then push. Push into stack. Push means push into stack. Number 2, if your operand comes, if your operand is coming, directly output, no push, no pop. So if operand, that is 0 to 9, any value, then direct output, no push, no pop, just direct output. Number 3 is push this bracket actually. You push means you push that actually. Alright, now the third rule is that if operator comes, push again. So if operator, what is the operator? Plus, minus, multiplication, division is the operator. Then push into stack. So you have actually 2 types of pushing. If there is a bracket coming like this, open, push, operator, push, operand, no push, no pop, direct output. Number 4 is if this comes, then pop till this. So please see, that is, if there is first one coming, pop till the first one. Another one coming, pop again till that one. So you understand now, this entire operation will take place into stack. I'm going to show you one by one. So, any question on the rules? CC4 very specific rules. So let's consider now a stack. We'll draw a series of stacks. Now what is coming? Is coming. So it gets into the stack. So there is a push. This is a push up push. Now next, I will write somewhere output. This is my output. Is going to output is nothing. The second, again another coming push. Now 2. All right. Next 4. No push, no pop. Got it out. Now after that, the operator coming. I'm just writing the operator because I don't have to write 4 because 4 is not going to this tab. All right. So what happens again? Push, right? Operator comes in. Then next, what is coming?
Operator.
2.
Print.
2 direct output. Look at it very carefully, okay? 2 direct output. Operator. Next, what is coming? This one. So, what is happening? Pop. But after pop, where is this pop output is going? So it actually is a pop now. What you are popping? Operator. So operator comes here. After that, any question? Yes. Up to now, this is pop. Because you said that if this comes, then pop till that. So you have 2. But first one closed. And you have only 1 left. Any other question? Because this is very important to understand. That means if I have another one coming, then this will be pop. Otherwise, it remains in this tab. Okay? After that, what is coming? Tell me. Plus is coming, right?
Yes, sir.
Plus, again push. So what happens here now? Plus. After that, what is coming?
C.
Another open bracket is coming. So again push. This is the push operation. After that, 6 is coming, right?
Output.
Output. And after that, division is coming, right?
Yes, sir.
So again push. After that, what is coming?
Open.
3, right?
3.
After that, closing, right?
Closing.
So you have this coming, this is pop. And after pop, concept is same. And now, finally what you have is another 2, right? I've just drawn here. You have
Minus.
the next one is minus. So you have a minus, again push, plus, minus. Then finally closing is coming. So when closing comes, you
স্যার
know,
আগে 8টা আউটপুটে হবে না
8 স্যার আছে
8 মাইনাসের পরে
মাইনাসের পর 8 ছিল
okay, 8 is here already, yes. And then closing is coming. Yeah. So now you have nothing in this stack. What comes first? Minus. So see what you see now. In fix, what is the output? But using stack. So you are given an expression, you parenthesize first, then apply stack. But in the actual case, in computer we give this actually and we generate this as output. You can ask me any question because this is a very fundamental concept of using a stack to convert an expression from infix to postfix.
স্যার লাস্ট ক্লোজিংটা একটু আরেকবার রিপিট
Last
করুন
closing is the same like other closing. এখানে আর কোনো last first বলে কিছু না। Closing মানে pop till open. এখানে একটাই আছে। এইটা আসলে সব পপ হয়ে যাবে। to 90. And stack is 8.
স্যার পোস্ট ফিক্সড কি এইভাবে দেখাবে আউটপুটে?
Yes, that will help.
স্যার এখানে প্রেসিডেন্সি নামে না?
Precedence we have applied actually. We did not, because it's already calendarized, is implicitly precedence is there. That's why you don't have to worry about precedence. Ask me any questions that you may have. So you see what happens is very interesting. How many pop? 1, 2,
3
and 3.
Last actus.
So you see how many closing? 1, 2, 3. So 3 pop, and the rest are all push. How many push? 1, 2, 3, 4, 5, 6. 6 push, 3 pop. Very straightforward calculation. Any question you can ask me before we go for exercise, but I will show you evaluation. And after that, we do exercise. Any question? So the rules are the most important, and this rule will apply while we are writing program. We'll be doing it in the lab, and we do one shot. We give this as input, we get that as output. The computer generates this output. Yeah, any question here? Clear about the concept? So I will show you now how do we evaluate an expression. Value, because you know the output. Value is 8 plus 2 minus 8. Output is 2. So we want to see how we generate this 2 using a stack. So you get an idea. Okay? Any question before that? No question? Yeah? No question, right? So let us proceed to see. I want to now see what happens in case of evaluation. This is actually conversion. But when we want to evaluate, we have to start from here. You understand that you have to now give postfix as an input and output will be the value. So we want to see how it happens. There are some rules also. So I'm going to write those rules and use a stack to convert them. But please remember, this is the input in case of evaluation. Output is the value. So let's see how it works. What we want to do, we want to use, so this actually, I will write the final expression is 4-2, then this, and after that 6-3 division, then 8 minus plus. That's my postfix, right? So I'm going to wipe this out now. So what we see now, this is my postfix expression, and I'm going to now write down the rules in case of evaluation, rules for evaluation. Rules for evaluation and rules for conversion is 2 different rules. Now in this case what will happen, this is my input. So what it will do, whenever there is operand, that means I'll write the first rule. If operand means I'm talking about any value between 0 to 9.
লাইটের জন্য স্যার এই পাশে দেখা যাচ্ছে না।
Okay.
যদি বাম পাশে লিখতেন ভালো হতো।
I need to use this part. In case, if operand, then is it okay? If operand, then push. Operand will be pushed. Okay? That means if operand then push, if operator, that means plus, minus, multiplication, division, then pop 2. There will be 2 pop. Pop, I will write 2, then 2 pops. Pop 2, operand, and apply operator and push the result. See, the concept is very simple, two rules. First rule is talking about that if there is an operand, you have to push that into the stack. If operator is coming any, then there are at least two will be popped up, because every operator actually needs two operators. And then do the operation and then push. So there are two pop, one push for every operator. So let's begin. Our stack, what is coming? 4. So 4 is into the stack. After that, what you are getting? 2. So 4, 2. So this is the push, this is the push, plain push. And after that, what is happening? A star is coming, operator. So if operator is coming, what you do? 2 pop, apply. That means what will happen is 4 multiplied by 2 is 8, and 8 comes in, 8 is here. So there are pop plus push. 2 operations. First pop, 2 item, apply, then push. So now you have 8 in the stack. So what happened? First operand push, second operand push, operator, pop, apply, push. Now next coming is 6, right? So you have 8, 6 coming, 6 push. That's another push. Yeah. After that, 3, right? 3 coming. You have 8, 6, 3, again push. And after that is a division operation coming, right? Division operation. So first pop is 2, 6 division 3 is 2, 2 is push, so 8, 2. You see? So what is happening is this.
Pop plus push.
Yeah, so this is actually pop
Then push.
and then push. So you see, the process is following the same way of doing it. And after that, what is happening is 8 is coming, right? 8 to 8 has come. So this is also push operation. Right?
Yes, sir.
Now the next operation coming is what? Tell me. Minus.
Minus.
Comes. So when minus comes, we already have 8 here. And then
2 minus 8.
8 minus 2 is 6. Is
স্যার
it?
এটা 2 minus 8 হবে না স্যার?
2 minus 8, the push is, you know that last comes first. So what will happen actually, the last, the 2 item, the last item will come appear with the first here. And then the last item. So what happens is there is a push, there is a pop. Hmm? This operation is actually, this is 6 by 3 because 6 comes last, 3 comes first. So it is 6 division 3. It will stack. So what happens is the first item is actually the last item. Operator is already here. So the first item is the last item and the second item is the first item. So it's actually 6 division 3.
স্যার তাহলে যদি
Same goes here. Yes.
তাহলে সেখানে 6 দ্বিতীয়তে আছে বলে 6 প্রথমে আসছে 6/3 হয়েছে, এখানে 2 দ্বিতীয়তে আছে বা 2 ওখানে 8 - 2 হয়ে গেল।
8 minus 2 ही হবে। It's actually huh?
প্লাসটা তো পরে আসবে।
No. It's you're right actually. You're right. It's actually not. It's 2 minus 8. It is minus 6.
জি স্যার।
Correct. So what happens is this one. You have 8 and minus 6. Because the concept is same. No question here. What you have is, I mean, minus 6 is here. Now finally what is coming?
প্লাস
Plus is coming. So now you have minus 6 plus 8. Minus 6 plus 8. 2. So here also you have all. So you see the final result is 2. This is a very important concept, that how you evaluate a fixed expression using stack. Suppose if I give you an infixed expression and ask that, okay, apply stack and evaluate. So what you do first? That's the infixed expression. What you do? Tell me. What do you do? I give you an infix, so you convert first into postfix. If it is saying that please convert also using a stack, so you use a stack to convert, and then take that postfix, apply the stack to it. Any question? You can ask any question, because this is a very fresh concept of how you evaluate an expression using a stack.
করে তার পোস্ট ফিক্স বের করতে হবে।
So what happens is, evaluate using stack always needs 2 operations. First operation is convert into postfix using a stack, and then evaluate postfix using a stack. Is it clear now? You have 2 operations all the time. First of all, you have to convert that into postfix using a stack, and after that you evaluate that postfix using a stack. So you have 2 series of stack operations. One set of operations is to convert, and the other set of operations is to evaluate. Any question? We are actually done with the stack application already. And we can begin actually, in the lab, we have the whole implementation. So don't miss that. We'll do everything in one shot. This one? Because this is actually, why is 2 minus actually 8, you see? Because it's coming, please remember, whenever there are operations, for example this one, imagine, there are 3 6. So 6 actually is going to be the first one. That comes last. And this is the last one which comes first. So when operator comes in, then operator actually has 2 sides. One is the left side and the right side. So the left side actually is the first side. The right side is the last side. So you will understand that there is no anomaly in the understanding. You have to work things. Let's do an exercise just to see whether you can do it. One exercise we'll do just to understand that yes, you can apply this concept. I'll say like this. Just an exercise. Evaluate the following using stack. The expression I'm giving is like this. So let's consider this one. But just this expression is given that evaluate the following using stack. So what you do, you know that first you will convert that into postfix using a stack. After that, take the postfix expression as output and evaluate that using stack. Office তুমি কি নিয়ে আসছো? কিসের? ক্লাসের সময় তুমি কোনোদিনও সাহস করে কোনো ক্লাসরুমে ঢুকবে না, বলতে অফিস একেবারে নতুন। In that case, what we do, we first convert postfix, evaluate, convert postfix, then reverse it to make it infix. Because it's actually reverse, you see? Just opposite. You understand, if you mirror the whole thing, this plus will come here. And they remain automatic mirrors. So this is actually mirror of this. So we sometimes call mirroring of postfix. But we have two options. We can use like the prefix, but prefix I have to reverse it. I cannot generally evaluate using prefix in the computer. I have to always use postfix. So postfix is widely used for evaluation of expressions. If the infix also cannot take infix after pare, but in that case you have to reverse it and then process. But process is always using postfix. Good question. So now we are actually done with the stack applications. I'm going to go. Yes, please. Yes. Oh, you saw that question already. Suppose X is an item. Let's consider X is 5 elements array. And if I want to say X of 1 is 5, 5 comes here. No? 5 comes here. So it's actually insert in the array. Insert in array. কিন্তু আমি যদি চিন্তা করি যে ওকে লেটস কনসিডার নাও লিঙ্ক টেস্ট ফর এক্সাম্পল you see how many operations you need to do. You understand now? Memory to bechi lagche, but things are very complicated na? Things are not easy here. So like this. So what happens? Suppose this is to insert. Insert needs one temporary allocation, number 1. Number 2 is search operation is needed. Search operation. Then number 3 is relocation. Relocation means insertion. So you see, that's why it takes more time than this. So computing is fun. Actually, it's very easy if you know how to look at it. So we are done with our class of today. Relax now.